Greetings and welcome. In today's video, we're going to talk about probability and odds. So probability is a number between 0 and 1 that represents the likeliness of an event occurring. Or likelihood. So if the probability of an event occurring is 0, that would be a certain failure, all right, or a certainty that it would not work out. And if the probability of an event was 1, that would be a certainty that the event is a success, all right. And success and failure are not necessarily defined in terms of positive or negative outcomes. It's defined in terms of what the probability was originally looking for. So let's see. Let's define a formula for probability of successes and failure. And actually, I think what I'll do is steal this right out of a snapshot here. So, the probability of success of an event occurring, if the event can succeed in S many ways and fail in F many ways, the probability of success is the number of successes divided by the number of successes plus the number of failures. Another way that I would define probability of success is the number of successes over the total is probably an easier way to think about it. And the probability of failures is the number of ways the event can fail over the total number of ways the event can occur. All right. And since successes is less than the total, right, this fraction is going to be less than 1. And since failures is less than the total number of ways the event can occur, this fraction will also be less than or equal to 1, I suppose. It could be equal. So this is how we define probability. One of the things I want to point out is, I guess, kind of a downfall in terms of the notation. If I have, I guess I'll call this beware. If I have p of some number, comma, some number, that is a permutation. Whereas if I have p and then parentheses and then some description, such as like yellow or Tuesday, or it could even be a number, but as long as it's not separated by that comma, this is asking the probability that yellow occurs. All right, so I just want to point out that the notation is very similar, and unfortunately it takes place in exactly the same chapter of the content. So this is the definition of probability. The definition of odds is similar. Now, odds is not necessarily a number between 0 and 1. It could be beyond that, but odds is the ratio of successes to failures. Man, I just failed at spelling failures there. There we go. All right. So odds of an event occurring, odds of yellow or whatever. Man, I can't spell yellow either. There we go. Would be the number of successes divided by the total number of failures. All right. So, so odds is a ratio. Typically in the real world, we'll see odds used in Gambling, right? 3-to-1 odds mean there's, it's 3 times as likely that a team will win compared to lose, right? Stuff like that. So let's do some examples with just these fractions. Suppose the odds of an event occurring, the odds of success, was 1 to 20. All right? And I want to figure out what is the probability of success equal to. I want to figure out what is the probability, or I guess maybe I'll ask the odds of failure first, equal to, and what is the probability of failure in this situation. So I don't even know what event I'm talking about. I just know that the success is a 1 out of 20 chance, or 5%. Sometimes probability can be represented as a percentage. Since it's a number between 0 and 1, that will also kind of sometimes happen. So since odds is defined as success over failure, that means S must be 1 and F must be the 20. So if I want to figure out the probability of success, that would be 1 over 1 plus 20, or 1 out of 21. All right. Actually, yeah, I just said a moment ago that it was a 5% chance. I lied. I'm sorry. Because this is not a percentage. Odds is a ratio. The probability is how I'd calculate the percentage. So whatever 1 over 21 is as a decimal could be converted to the percent. So this would be the probability of the event occurring. The odds of failure. All right. Now, since I'm looking at failure as being the quote-unquote success in this case, odds of failure would equal F over S. So that ratio is 20 to 1. All right? So that's the odds of failure. And then the probability of failure. How many ways can failure occur? 20 ways over F plus S, or over the total number of ways they can occur. So probability of failure is going to be 20 over 21. All right, so there's just some ways you can kind of convert between the units of the situation. Let me actually do one more example in the other direction. What if the probability of failure of some event was 3 out of 5, or 3/5, or 0.6% chance that I'm going to fail at something, all right, or whatever it is. So let's figure out the other 3 possibilities. So let's figure out, I guess we'll first define. So S, well actually, F I know is going to be 3, right? Because F is the numerator, the number of ways the event could occur. The denominator for probability, recall, is S plus F. So S plus F is 5. So if I want to figure out the value of S, I'd actually have to substitute 3 into F. That's just my son Griffin kind of making some fuss. Don't worry, he's taken care of right now. So S plus 3 is equal to 5, so that means the number of ways the event can succeed is 2. And now that I know that, I can then answer questions like, what is the probability of success? So that would be the number of ways I can succeed over the total. I guess that's actually another way. At this S plus F, I could have defined it as the total, right? Number of ways the event could occur. So I already knew that that's 5. The odds of success is the ratio of S to F, so that's 2 to 3, right? Which, by the way, if odds is equal to 1, that means it's equally likely that you would succeed to fail. If odds is less than 1, that means that I am less than likely to succeed. And if odds is greater than 1, then I would be more likely to succeed than fail, right? And then odds of failure of this particular event. Oh, let's see. It looks like my writing tablet just failed on me here. That was improbable. That is really unusual. Just a moment. Tinkering, plugging back in, and I've got power. What's going on? All right. Oh, it just died again. Here, let me plug it in, see if switching over to wireless would help, although you'd think that would be less likely. I had it hardwired in. And okay, it's okay, Griffin, it's working out. All right, here we are. Whew. My goodness. So the odds of failure would be the ratio of F to S, which would be 3 to 2. All right, so I just want to point out that once I can find 2 out of 3 of the successes, failures, or totals, I can always find the third and then answer any of these questions like that. So let's actually look at a probability question. And probability is very much so going to relate to combinatorics because I'm always interested in the number of ways an event can occur, right? The number of ways it can succeed, the number of ways it can fail, and the total number of ways it can occur. So that's where combinatorics is going to come into play. But although sometimes some of this can be just a matter of regular old counting. So let's see. So I've got 5 yellow marbles, 6 blue, and 4 white. Let's see. Actually, that's not quite white. There it is. 1, 2, 3, 4. So here's all my marbles. All right, jumbled in a bag. So let's look at part A. It says, what is the probability that a marble selected at random will be yellow? Now, this is key in order for probability to apply. The likelihood of, or I guess the chance of any single outcome occurring, we are considering equally likely in this situation, right? So like these marbles are all jumbled together in a bag. I'm not able to see the marbles. I'm reaching in blindly. The randomness of this is what's going to allow me to use probability to figure out the likelihood of the event. All right. But if for some reason, like if the yellow marbles were much larger than the others, right, then I would somehow have to weight that their likelihood of being chosen differently than the others, right? Things like that to consider. And actually, that's one of the reasons why I don't know if you've ever participated in like a raffle or something where you like put your name on a slip of paper in a big bowl and someone draws it. It has been argued that if you fold it in irregular patterns, so not like just kind of like fold in half and then in half and half it again, but kind of like fold it so it's got as many awkward angles on it, it's got a greater number of surfaces and edges that the person grabbing it would likely grab your paper compared to someone else who has kind of flattened theirs in a number of folds so that it's only got a single surface, right? So there's a way you could kind of work the probability into your favor. All right, so let's figure this out. So what is the probability of this being yellow? So what is the number of ways I could successfully choose a yellow marble? Well, there are 1, 2, 3, 4, 5 yellow marbles to choose from, right? So that is 5 that I'm counting here. And then what do I divide this by for probability? Well, I divide by the total number of ways the event could occur. So in order to figure that out, I have to figure out how many different ways could I draw a single marble out of this bag. Well, there's 5 yellow, 6 blue, and 4 white. So that's a total of, I believe, 15 ways the event could occur. So number of successes over the total number of ways, I could and should always reduce this if possible. 5 goes into 5 once, into 15 3 times. So 1/3 is the probability of drawing a yellow marble, right, out of the bag. All right. And like I said earlier, you are allowed to represent this as a decimal sometimes, and it also would not be wrong to represent that as a percentage. Typically, though, most of the time we'll be working with probabilities that are fractions. So there's part A. Actually, let me point this out. There is another way I could have set this up using combinatorics. I kind of counted it, but not always will that be an easy situation. Right? Sometimes I'll be working with a very large number of things that counting them would be inefficient or ineffective. So I technically could have said, well, the number of ways I could pick a yellow marble, there are 5 yellow marbles, and I'm picking 1. So how many ways can I pick 1 yellow marble? right, is how I could set up the number of successes in terms of combinatorics. And then how many ways could I select any marble, right? Any single marble. I'm picking one marble out of all 15 here. So my denominator would be combo 15-1. And in these cases, both of these combinations happen to reduce to the same fraction and still equal 1/3. So here's kind of like a somewhat of a more elementary level perception of the problem where you're just kind of counting it. And then here's where we're starting to use some combinatorics to represent the situation. So let's look at part B. What is the probability that the marble selected will not, all right, keyword not, be white? In terms of logic, sometimes the tilde is a symbol that means not something, so kind of not this happening, right? The opposite of that event occurring. So the probability of not white, my numerator, I guess I could put words to this first, would be how many not white marbles could be selected. All right, if you want to kind of put words to this, if that helps you, if you're more of a verbal person and trying to interpret this. And then I'm putting this over the total, so how many ways can any marble be selected? Marble be selected, right? So that's kind of the words I would put to that if we were to use the language. So how many not white marbles are there? Well, there are 5 yellow marbles, which are not white, and there are 6 blue marbles, which are not white. So that's a total of 11. That looks kind of like just like a meh face right there, but that's 11 over a fraction bar, right? And then over the total number of ways I could pick a marble out is 15. So 11/15ths, actually that's fully reduced there, isn't it? So that would answer my question. And then if I was to use combinatorics, my numerator, the number of not white marbles to pick from was 11, and I'm choosing 1. The number of marbles to pick from is 15, and I'm choosing 1, and I'd still get 11/15ths as my answer. Let me actually ask some of my own follow-up questions. What if, when choosing 2 marbles, all right, so this would be, man, what is wrong with spelling today? That's all right. When choosing 2 marbles, now by this I mean I'm either reaching into the bag and grabbing 2 marbles simultaneously and taking them out, which eliminates the possibility of having the same marble twice, right? That's physically an impossibility. Or you could interpret this as reaching into the bag, grabbing a single marble, holding it, reaching into the bag again, and grabbing another marble. So it eliminates the possibility of the same marble being chosen twice. So this is, you could view this as kind of 2 separate events that are dependent on one another, since the number of ways the event could occur the second time is less than the number of ways the event could have occurred the first time, right? There's fewer marbles in the bag the second grab. All right, so a lot of explanation for this question. So what's the probability that I get 2 yellow marbles? So how many ways could both of those marbles be yellow? And now this is where I can't necessarily just count this. All right, so I've got to figure out how many ways can I pick 2 marbles out of the 5. Well, I could have chosen this one and this one. I could have chosen that one and that one, that one and that one, that one and that one. I could have chosen this one and this one, or this one and that one, right? And that's not going to be an effective way to figure this out. So what can we do? We can use combinatorics to represent this problem. There are 5 yellow marbles to choose from, and I just want to know how many ways can I pick 2. That's a combinatorics question. That's a question I would have asked in a previous video, right? So that's going to tell me the number of ways I could successfully get 2 yellow marbles. And then let's put this over the combination of, well, there are, what's the total number of ways I could just pick any 2 marbles? Well, I have 15 marbles to choose from, and there are 2 that I'm picking, so how many ways can I pick any 2 marbles from the 15? So I'd use combinatorics to represent that as well. And now I could kind of do all my fancy combinatorics math. 5 factorial, 5 minus 2 factorial is 3 factorial over 2 factorial over, and this would be 15 factorial over 13 factorial times 2 factorial. So let me actually, I'll do this a little bit by hand, but I wouldn't consider you wrong for reaching for a calculator at this point and using your calculator to figure out the combinatoric. So let's see, so this is the same as 5 times 4 times 3 factorial over 3 factorial times 2 over 15 times 14 times 13 factorial over, man, that's a really ugly 14, but just pretend it's cool, over 13 factorial times 2. I'm not writing 2 times 1 because it's not necessary. Let's see, 3 factorial, 3 factorial, 13 factorial, 13 factorial cancel out. 2 goes into 4 twice. This 2 goes into 14 7 times. And let's see, so I'd be left with 5 times 2 up top is 10. This denominator is 1, so it's just 10. Denominator, if I wanted to call it my own cool name. And this is 15 times 7, so that's 70 plus 7 times 5 is 35. 105, I believe. And then both of these are divisible by 5, so that's 2 over 21 would be the number of ways that could occur. So here's an example of, it would have actually taken me a while to figure out the number of ways. I could have chosen 2 from 15, but instead of counting them by hand like I was able to for these simpler questions, I was able to use combinatorics to kind of expedite the process. And I guess part D, I just want to ask this question. I'm going to do the setup and not the calculation for sake of time, but what's the probability of 1 yellow, exactly 1 yellow, and 1 blue marble being selected? And this is kind of where this is a little bit more complicated now. So I got to figure out how many ways can I choose 1 yellow marble. Well, there's 5 and 1, right? And how many ways can I pick 1 blue marble? And these are independent events from one another, right? There are no fewer blue marbles for the time that I picked that yellow marble, right? There's still just as many. And how many blue marbles were there? 6. Oh, scroll down too far. Getting ahead of myself there. So there's, how many ways can I pick 1 of the 6 blue marbles? And then I'd put this, multiplying these, right, because they're independent events, I can do so. And that will give me the total number of ways I could pick 1 yellow, 1 blue, which in my world of probability, that's the number of successes, right? That's exactly what I wanted to find. And now my denominator, I'm still picking from 15 marbles, and how many am I picking? I'm picking 2. So this is kind of a little bit more of a complicated question, and the better we are at combinatorics, the better we'll be at probability, because I'm just calculating the number of ways this event can occur over the total number of ways that this could occur, right? So that's what I'm doing. And then we could go from there to figure out what that answer would be. So let's, last quick example. It says, a circuit board with 20 computer chips contains 4 chips that are defective. If 3 chips are selected at random, what is the probability that all 3 are defective? So the thing I'm looking for, the probability that all 3 chips are defective. All right, so what's my numerator going to be? The number of ways I can pick 3 defective chips, right? And what's my denominator going to be? The number of ways I can pick 3 chips out of any of the chips, right? So, so my numerator, how many chips are defective? There are 4, and I'm choosing 3 of them, right? So combo 4, 3 would be the numerator. And my denominator, how many chips are there total? There are 20. And I'm choosing 3 of them. So I could figure this out. I guess I'll do this. Feel free to stop watching the video if you really want to. I'm just going to be simplifying some stuff here. 4 minus 3 is, right, 1 factorial. Kind of not necessary. 3 factorial, right? All over 20 factorial over 20 minus 3 is 17 factorial, and times 3 factorial. All right. Alright, so what's this look like? This looks like 4 times 3 factorial over 3 factorial. 1 factorial is just 1. If you want to have that there, you still could. 20, let's see, give myself some room. 20 times 19 times 18 times 17 factorial, all over 17 factorial times 3 times 2 times 1, or just 3 times 2. So let's cancel out what we can. This is my favorite part, by the way. I love canceling stuff out. 3 factorial, 3 factorial. There you go. There's 17, 17 factorial, cancel out. Let's see. 2 goes into 20 10 times, and 3... Oh, perfect. I guess, I could have canceled it out this way. Lots of ways I could do it. 3 and 2 is 6, and 6 goes into 18 3 times. So let's see what we end up getting. My numerator is 4 over 1, or just 4. My denominator is 20 times 19 times 3. What the heck? What's 60 times 19? I'll reach for a calculator for this one. 1140. And yeah, those are both divisible at least by 2. And actually, they reduced all the way. 4 divided by 4 is 1. 1140 divided by 4 is 285. So, and if I wanted a percentage, we're talking 0.0035 is the decimal. So 0.3.5% chance of this occurring, right? So it's unlikely that I would happen to choose all 3 defective chips. And this type of question actually is a huge deal in the real world. This is quality assurance is a means of kind of testing the reliability of your product going out, and they typically won't test every single product that leaves a factory because that's a lot of man hours to hire people to test every single product. But what they'll do is they'll randomly pick a selection of products that come down the assembly line, and if they have a certain number of them not be defective, all right, they'll consider their chances of, they'll find actually the chances of, what percent of them likely will end up being defective if none of them are found after choosing 10 or something like that. And then they'll eventually just say, well, that's good enough, right? Like, they might still be shipping some out that are actually 100% broken, but they consider their odds, and they say, well, we might have a handful of upset customers, but we'll be able to replace theirs, they'll be on warranty, etc. And, it's better to have a handful of upset customers that they can, take care of and give new working products to, rather than have to pay their staff to test every single item that leaves the door. So that's kind of an area of real-world practice that can be done in. So anyways, this is my first video on probability. We'll do a handful of other ones coming up. So thanks for watching, and I'll talk to you guys next time.